This is a video on how to solve a right triangle. Solving a right triangle means to fill in everything. You find all the angles, all the missing angles, all the missing sides. And so we're going to go ahead and do that. Here, somebody listed this out like this, and that's fine, but I would prefer, and if you hadn't put that there, I would prefer you write your answer like this. I'm going to put, I don't know, angles or sides. I'll put angles, and here I'm going to put sides, right side by side, so I can kind of think about it this way. A equals whatever it equals, B equals, again, whatever it equals, and C equals whatever it equals. Opposite big A would be little a. What's that side length? Big B, or little b, sorry, what's that side length? And then little c is what's that side length? And typically, if they don't say otherwise, we know that C is going to be our 90-degree angle, so we can go ahead and fill that one in. Over here, we're going to draw out a random right triangle so that we can label it. There's my right angle. There's my C. That's little c. There's A. There's little a. There's B. And there's little b. If you wanted to, you could switch those. That wouldn't matter. We put big A here, then little a here, big B here, and little b here. And so what we know, we'll go ahead and fill this in. We know that C is 90 degrees. We've got that. They've given us that C equals 22. Let's go ahead and write that. That's 22. And then A is 5. So let's write that. That's 5. And so we can see then what we're looking for. I do not know either angle A or B. And so I'm probably going to start with that. Let's go over here. A is 5. So A is 5 and C is 22. And so then we know what we're looking for. A and B, angles A and angle B, and then little side B. So I'm going to say, let's find angle A first. Well, I'm going to put my little theta there. That's what I'm looking for. And so this is the opposite side. Opposite the right angle is always the hypotenuse. And so I'm not going to bother labeling this side yet because this is the one, these are the two sides that I know. Oh, sorry, this is opposite, excuse me. Opposite. I know this side and I know this side. I'm going to leave this B alone so that I can focus on what I know and which ratio to use. So I'm going to go, okay, so, ka, toa. And that's going to help me to decide which trig ratio to use to write my equation. So I've got my hypotenuse, and I've got the opposite leg. So O and H. O and H, that's sine. I'm going to use the sine. So the sine of angle A, and if you'd rather put theta, that's fine, but I'm going to put A so I remember what I found. The sine of angle A is equal to O, which is 5, over the hypotenuse, which is 22. And then, in order to solve for A, I'm going to use the inverse sine. A then is equal to the inverse sine of 5 over 22. And I go to my calculator to get that angle. Okay, let's see here. You do need to make sure that your calculator is set to degrees. Mine is. You can watch some of my other videos to figure out how do you change the degrees if you've got it in radians. Make sure you ask your teacher. That could be me or somebody else, but make sure you ask your teacher. So we've got second function sine. Just double check. Yep, second function sine, that's inverse sine, of 5 over 22. And that gives me 13.13. This 3 is right next to this 6, and since 6 is 5 or greater, that rounds that to 4. So it's 13.14. A then is approximately equal to 13.14 degrees. Now I'm going to show you a couple different things here. If I wanted to, I could have done the same thing for B. And I would have said, oh, what does that mean? Let's look. If I say, instead of putting my theta there, I'm going to put something here, B. Let's. I don't want to confuse you with theta, so we'll do, I don't know, let's do alpha. Alpha there is the angle B, but now I see the hypotenuse is still the same. It hasn't changed, but 5 now is right next to the angle, so this is the adjacent side. So if I've got A from adjacent and H from hypotenuse, A and H, that's the cosine. And so then I go, oh, okay, well, let's write that equation. The cosine of B is equal to the adjacent, which is in this case 5, over the hypotenuse, which is 22. And then once again, I'm going to put B is equal to the inverse cosine of 5 over 22. And when I go to my calculator, I see the inverse cosine of 5 divided by 22 is 76.86. But this 6 right next to it is a 3, and that's 4 or less. So that rounds that down to 6. So it's 76.86. B then is approximately equal to 76.86 degrees. Remember, we're looking, the capital letters B, we're looking for angles, so you need to make sure that you write that in degrees. Same over here. We did this. Capital A, that was an angle, and we put our answer in degrees. Make sure you're labeling those. It's going to help you to avoid confusion. So, the other way I could have done this, as soon as I found that this is 13.14, I know that C is 90 degrees. A was 13.14 degrees. But because I found them both with trig ratios, I could just double check this. Is 13.14 plus 76.86 plus the 90, what does that give us? 180 degrees. So we could have just taken 180 degrees, subtract the 13.14. Once we found what that was, we already knew that the other one was 90. We would have gotten 76.86. So we could have done it that way also. And you can use both methods, one to check the other if you'd like. Sometimes it's just a rounding mistake. Might have given you 181 or 180.7 or something other than exactly 180. So watch the rounding on those things. Okay, so here, B then, I'm going to change the color on this just so you can see kind of what I've done. 13.14 degrees, and this one is 76.86 degrees. And then I need to find little a and little b. And I think I do know one of those. Little a is 5. Little a is 5. So I'm going to go here. This is 5. So now I need to find b. And again, I've got options. I could use one of the trig ratios, or I could use the Pythagorean theorem, or I can do one or the other. I can use the Pythagorean theorem in this case because I have two of the side lengths. You can't use the Pythagorean theorem if you only have one. So I could say, I don't know, let's go 5 squared plus b squared equals 22 squared. The square of the length of one leg plus the square of the length of the other leg is equal to the square of the length of a hypotenuse. And so this gives me 25 plus b squared is equal to 22 squared. I don't have that memorized, so let's see, 22 squared, that's 484. So this is 484. I subtract 25 from both sides. 484 minus 25 is 459. So b squared equals 459. B then is going to be approximately equal to the square root of, let's go ahead and it's going to be exactly equal. B is going to be exactly equal to the square root of 459. But that, I imagine, unless it's a perfect square, is going to be approximately equal to something. Let's see. The square root of 459. Yeah, it's a decimal. So this is 21.42, and this is the 2 in the hundredths place. So the 4 next to it rounds it down, 21.42. So this is approximately 21.42, and that's what B is. We found that with the Pythagorean theorem. So let's write that in here, 21.42. But what would happen if we'd have used a trig ratio to find it? Because we could have done that. If I want to find what is B, I know, for example, right now that this angle B is 76.86. 76.86 degrees. And for that, B is the opposite. And the hypotenuse is 22. So I'm going to use those two. I could have used the 5, but I'm choosing to use these two. You've got choices now. So I'm going to use that 22, the hypotenuse. Opposite is B. So I've got O and I've got H. And that would mean, yeah, I got the sine. So I'm going to fill out my equation. I'm going to say the sine of 76.86 degrees is equal to the opposite, which is B, over the hypotenuse, which is 22. And to solve this, I would just take this and multiply this by 22 on both sides. And that would just give me what B is. So I just have to put that in my calculator. What is it? What's it going to give me? 22. 22 times the sine of 76.86. And I hit enter. And it gives me 21.42, et cetera, et cetera. Now, it's not exactly the same. You see that these digits change a little bit after here, but it still rounds to 21.42. So that's pretty good. And that just coincides with what we found by using the Pythagorean theorem. And so we could have done it either way, and you can use one way to check the other way. So those are our answers, which, if we want to write them up in here, that would be 21.42, and this would be 76.86 degrees. Make sure you label your angles as degrees so you are keeping those straight. And then A is 13.414 degrees. And if there are units attached to these, make sure that you use those on the side lengths. So there was not in this case, so we'll just leave it, but know that it's a length, and so keep those units if you can. Here we go.